We are studying the physical properties of haloalkanes and haloarenes. We already have finished the melting points and boiling points of haloalkanes. Now let's take a look at the melting points and boiling points of haloarenes, right? Some of the important points here are, the first thing you will remember is that boiling points of haloalkanes and haloarenes having same number of carbon atoms. Haloarenes are cyclic, but it cannot be only benzenoid. I've told you this so many times. So 6 carbon number से ही start नहीं होता. It can start with 3 also. There's a cyclopropane का एक compound है which is aromatic in nature. So boiling points of haloalkanes and haloarenes with same carbon atoms is the same, right? Irrespective of the different chemistry, these are alkanes, these are arenes, but if the number of carbon atoms is the same, what we observe is that their boiling points are the same, right? The second thing I'll write down a trend. And what is the trend we observe? Let's take a look. This is our benzene ring. And on our benzene ring, we have iodine. So this is iodobenzene. After that, we'll have bromobenzene. After that, we'll have a chlorobenzene, and we'll have a fluorobenzene also, right? Now if we write down the values of boiling points, this is what happens. This is 462 Kelvin, this is 429 Kelvin, this is 405 Kelvin, and this is 358 Kelvin. Now the trend is the same. For the same AR group, aryl group, in this case the benzene ring is the aryl group. For the same aryl group, boiling point increases with the increase in the size of the X atom. Since iodine is सबसे बड़ा, it is bigger than bromine, which is bigger than chlorine, which is bigger than fluorine. This is the trend. Iodobenzene का boiling point सबसे ज़्यादा होगा because iodine का atom in सब में सबसे बड़ा है, right? Also, if this happens, you will remember also that the boiling point as well as melting point will show an increase always with what? With the increase in the size of aryl group for the same X atom, the way we studied it in haloalkanes. If the X atom is the same, if all of them are chloro, all of them are bromo, or all of them are iodo, but if you're changing the size of aryl group, you're using a 6-membered ring, you're using a 5-membered ring, a 3-membered ring, boiling point shows an increase when the size of that aryl group increases, right? Now in these also haloarenes, the point about isomeric haloarenes is very, very important. Let us see what happens in isomeric haloarenes. Isomeric haloarenes होते कौन से हैं? These are the dihalogen derivatives, right? For example, we have 3 of them. We have ortho, para, and meta. I'll write down the examples of chlorobenzene. 1,2 dichlorobenzene. This is an orthoisomer. The next one that we have is 1,3 dichlorobenzene. This is the meta isomer. And finally we have 1,4. This is our para isomer. And if we write down the values, 256 Kelvin, this is 249 Kelvin, and this is 323 Kelvin. This is what happens in case of isomeric haloarenes. Why does this happen? As you can see, this is symmetrical. सबसे ज़्यादा इसी का boiling point है, even melting point also. This is symmetrical. Since this para-isomer is symmetrical, its molecules are closely packed, tightly held together in its crystal lattice. सारे molecules की close packing है, they're tightly held. That is why its melting point is higher than that of this, जिसकी इससे कम close packing होगी, जिसकी because of steric hindrance इससे भी कम close packing होगी. This is something you need to remember here, that more the symmetry, more is the boiling point, because more the symmetry, more closely will be those molecules packed in their crystal lattices, right? These are just three very simple important points about the melting and boiling points of haloarenes.